everybody, welcome to example B from section 5.3 elimination method. This method gets a little bit more tricky, and so we're going to go through an example of when they don't just eliminate when you add two equations together. Alright, so there's a little bit more work to be done, and these numbers get a little nasty, so just make sure you have your calculator with you. Alright, so example B, a molecule of hexane, C6H14, has 6 carbon atoms and 14 hydrogen atoms. Its molecular weight in grams per mole is the sum of the atomic weights of carbon and hydrogen is 86.178. The molecular weight of octane, C8H18, is 114.232 grams per mole. Octane has 8 carbon atoms and 18 hydrogen atoms per molecule. Find the atomic weight of carbon and hydrogen. Wow, that seems like a lot, but let's break this down. So let's define some variables and write a system of linear equations in standard form for these molecular weights. Okay, so first let's just use some variables. Let's say C is the weight of a carbon. So we're going to let C equal the weight, E-I-G-H-T, of carbon. You're watching the pen do this, right? And it's not going through. The weight of the carbon atom, R, okay, there we go. The weight of the carbon molecule, right? The weight of the carbon in grams per mole. Weight of carbon, in grams per mole. And we don't really need to know what any of those things mean. That's just kind of what this says, so we're okay. And let's let H equal the weight of hydrogen in grams per mole. Alright, so now we have our variable. Now that we have our variables, let's see if we can write an equation. Alright, so I'm looking at hexane first. So what I'm going to do is I'm going to write my equation for hexane right here. So I'm gonna write it over here. So I have hexane. And so here's my equation. Well, I know that I have C6H14. We know we have 6 atoms of carbon. So it's going to be 6 times the weight of the carbon plus how many atoms do I have of hydrogen? Well, there's H14, so there should be 14 hydrogen, right? So we have 14 hydrogen atoms times the weight of the hydrogen in grams per mole is going to give me the weight of the sum of the carbon and hydrogen, which is 86.178. So it's 86.178. All right. So there's an equation for hexane, right? 6C plus 14H equals 86.178. Okay. So then what would the equation be for octane? The equation for octane, we have to figure out how many carbon there are. We know that has 8 carbon, right? C8. So there's 8 times the weight of carbon plus how many hydrogens does octane have? Well, it's 18 plus 18H equals, and how many is that? 114.232. 114.232. All right. So we defined our variables. Check H and C. We wrote a system of equations in standard form for these molecular weights. Alright, so we want to use elimination now to solve this. So this all was for part A. Let's do part B using elimination. Well, if I just add or subtract these, if I take 8 minus 6, I get 2. 18 minus 14, I get 4. So I'm not going to eliminate anything by just adding or subtracting these equations together. So there's a problem. So what we have to do is think about fractions and think about trying to get like common denominators. We're going to say, can I multiply this equation by something, and can I multiply this equation by something? So that way either the coefficient in front of C's is the same, the coefficient in front of H's is the same. Alright, so I can either use 8 and 6, or I can use 14 and 18. And it doesn't matter which one you choose, but I'm going to choose 8 and 6 because they go together a lot easier than 18 and 14. Alright, I can find numbers that both of these go into. I can't find them here. Alright, so what number do both 6 and 8 go into? I know 6 and 8 both go into 24. So I want to have 24 C's for both of them. Alright, so that's what I'm looking to get. I'm looking to write 24 C's. Okay, so let's go back and just get our equations here really quickly. Alright, so we have our equations, and I want to have 24C. So what do I have to multiply this equation by to get 24C? Well, I need to multiply 6 by 4, so that means if I want to multiply this by 4, I have to multiply every single thing by 4. Otherwise, it's no longer the same equation. All right. So I'm just going to write some of this out. I'm going to do 6 times 4, which is 24c, plus what's 14 times 4. And I'm actually going to write this down just so I remember. I'm going to write down this multiply by 4 just so I remember. All right, so 14 times 4 is 40 plus 16 is 56h. And that's going to equal, oops, I don't need that. It's going to equal 86.178 times 4. And I'm going to get that number in a little bit. I'm just going to write this out for now. All right, and we'll actually get that to be a number in a little bit. Okay, so now what I'm going to do is I'm going to multiply this one by 3. I also want a 24c. So that means I have to multiply everything by 3, and this whole row has to be multiplied by 3. So that means I'm going to have 24c plus, well, what's 18 times 3? That's going to be 30 plus 24 is 54. H, and that's going to equal 114.232 times 3. All right, so let's grab our calculators and figure out what these numbers are. And there they are. So those are the numbers, okay? So now we have this equation right here, and I'm just going to put this, going to cover that one up because we don't really need it anymore, and it's going to get in the way. All right, so now what we want to do is we want to eliminate one of these two variables. Now the reason I didn't multiply by a positive or negative is that I want to be able to verify that whichever number is larger, I can put a negative by. All right, I want to make this as easy as possible for me without negatives if I can help it. So I can take the top, make those all negative, or I can make the bottom all negative, I can add, subtract, whatever. But I know I want to get the bottom to be negative, so 56 minus 54 would be easy to do. 344 minus 342 would be easy to do. So what I'm going to do is I'm going to subtract. And I'm going to actually write this in red now because this is something I'm going to do every time. Because if I just write minus here, sometimes I forget to subtract and I add. So I'm going to do a negative here and a negative here. That way when I go through and I do all this, I'll get just my answer, right? And I'll do this correctly. Otherwise I might add. So I like to just put the minuses in every time. So 24c minus 24c, they should eliminate to nothing, right? That's not an x, that's like a nothing. No possible answers here. All right. 56 minus 54 is going to be a positive 2h, and 344 minus 342 is going to give me 2.016. All right. So now all I have to do is divide by 2. Divide by 2. All right, and I end up with h equals 1.008. Okay, so that is, if we go back and say, what does that really mean? H is the weight of hydrogen in grams per mole. All right, so H is 1.008. So are we done? Did we find our solution like Part B asked, use elimination to solve the system? Hopefully by now you're saying, no, Mr. Bartman, we haven't done that because I still need to figure out C. Okay, so now I've said, doesn't matter which equation you plug it back into. I can plug it back into the top equation. I can plug it back into the bottom equation. Here's something else I can do. I can plug it back into either one of my original two equations. So it doesn't matter which one you plug it into. And what I'm going to do for the sake of what we're talking about is I'm going to plug it back into this one. All right? It's the equation with the smallest numbers, so it should be the easiest to do. All right? So now I'm going to plug this 1.08 into this H and solve for C. All right? So I'm going to use that equation. So I'm going to do it over here. So I have 6C plus 14 times 1.008. And that's going to equal 86.178. All right. So if we get 14 times 1.008, you get 14.112. So we have 6C plus 14.112 equals 86.178. All right. So now we have to subtract 14.112 from both sides. Right? So we have 86.178 minus 14.112. And I get 72.006. So I have 6C equals 72.066. And then I just divide that by 6. Well, I know 72. 6 goes into 72. Right? 6 goes into 72 12 times. And then 66, 6 goes into 66 11 times. So that means I can say that C equals 12.011. Alright? So now do I have a solution to my system of equations? Yes, I do. I can take 1.008 for H, this is the weight in hydrogen in grams per mole, and 12.011 for carbon in grams per mole. Alright? So now part C, the last part says check your solution with the original equation. So what I'm going to ask you to do is to take these numbers, plug it back into this second equation, and see does that work out. Alright, so plug it into here and see if you get 14.232 when you plug in these numbers for H and C. Alright, there you go.